Hi everyone, and welcome to this session on Lambda Variables, the mysterious cousins of the new Lambda function. I'm Charles Williams. I've been an Excel MVP since 2009. My main interests in Excel are the formula language itself, and in particular the functions. I've written over 100 new Excel functions that do all the things that Excel should do, but doesn't, of course. Anyway, so I'm very interested in the new Lambda function, and diving into that, I came across the rather mysterious use of them as Lambda variables. So that's what this session is all about. I'm going to start by talking about function arguments and parameters and how they get passed, how the arguments get passed to the parameters of the functions. Then we're going to start talking about Lambda variables and how we pass them to functions. We're going to cover what functions in Excel are capable of handling Lambda variables and Lambda functions, because although they say that Lambda variables are first-class citizens and therefore should be able to be used everywhere, that turns out not to be quite true. Then we've got a set of examples of doing grade calculations using lambdas. We're going to use the new map function to create alphabetic grades from scores. We're going to use by row to create grade point averages from the alphabetic grades. And then finally we're going to wind up with the magic gradings function, one function to rule them all, using, of course, lambda variables. When you start using a function in Excel, or indeed look at the documentation for a function, you'll see that the parameters of the function are described. So for XLOOKUP, the parameters are, the first three parameters are the lookup value, the lookup array, and the return array. Of course, when you actually use the function, you give it real arguments that get passed to the function. So for this example of XLOOKUP, I'm giving it 42 as the lookup value, C2 to C5 as the lookup array to look up in, and A2 to A5 as the return array. And so passing it 42 gives me the answer 30, as you'd expect. Notice that the arguments are being passed by position. So the first argument in this XLOOKUP 42 gets passed to the first parameter, and the second argument gets passed to the second parameter, third argument gets passed to the third parameter, and so on. Sometimes the arguments to functions are calculated arguments. So here with the XLOOKUP example, we've got 35 plus 7. So that arithmetic expression doesn't actually get passed to XLOOKUP. Excel first calculates that little sub-expression, 35 plus 7 makes 42, and passes the 42 to XLOOKUP. The plus sign on the front of the C2 to C5 forces Excel to resolve that reference there, and does, instead of passing the reference to XLOOKUP, it actually passes the values. Whereas the A2 to A5, it passes the reference. And this gets to be a crucial difference when we start looking at how lambdas operate. In this case, we're passing a function, sum 35(7), to the XLOOKUP as the value to look up. And again, it doesn't actually pass the function to XLOOKUP, it passes the result of the function. But when we come to lambdas, something different may be happening. Excel allows us to pass various different types of argument to functions, but not all functions will accept all argument data types. So we can pass to XLOOKUP, for instance, we can pass numbers, booleans, text. We can try passing errors, but it doesn't really work very well. You try looking up NA in a table, and it doesn't work. It just propagates the error up. So it always returns NA. Obviously you can pass it lookup ranges, and you can pass lookup arrays. Some functions in Excel, like SUMIFs for instance, the first argument of some ifs must always be a range. You can't pass it an array, you can't pass it a calculated argument, it's got to be a range. So there are different restrictions on various functions within Excel. And that leads us on to what the differences are in this area for Lambda functions. Okay, so it's time to talk about Lambdas. Now, remember that most functions pass arguments to parameters by position. But for Lambdas, we've got to do something slightly different, because inside the Lambda, we've got parameters and then we've got a calculation expression. And the way these parameters are passed to the calculation expression is by name, not by position. Okay, I've got x and then y, but in the calculation expression, I've got y and then x. And so the value of y that's been passed as an argument gets passed to y here, and similarly with x. Okay, so within Lambdas, parameters get passed to calculation expression by name. But of course, the arguments get passed to parameters by position. Whew. Okay, so the 7 is the first argument that gets passed to the first parameter x, which then gets passed by name to the calculation expression in the Lambda. The second argument for the Lambda is 35. That gets passed to the second parameter y, which then gets passed by name to the calculation expression. Okay, so this can be a little confusing at first, but bear with me, it's very important that we understand this. Parameters to calc expression by name, arguments to parameters by position. Okay, we're 7 minutes into this session and we're finally getting to talk about Lambda variables. Yay! Okay, here we go. Now here we've got some arguments to a Lambda, 7, 35, and another Lambda. Woo! Okay, and there's parameters for the Lambda. We've got A, which is going to take the 7, B, which is going to take the 35, and F, which is going to take the Lambda. Okay, so F is a Lambda variable. But when it gets passed to the calculation expression, yeah, it becomes a real Lambda, and it can take the arguments, the parameters, from the Lambda by name. So this Lambda j plus I gets passed to F as a Lambda variable, which then is used in the calculation expression with two arguments A and B. So the A is being used as the I in the Lambda, the B is being used as the J in the Lambda, and then the two are added together to give 42 again. Right, so this function here has got two arguments and they're being passed by position to the actual Lambda itself. Okay, so right, so we've got a combination of passing arguments by position and passing them by name. This is what happens when you use a Lambda variable. Now the advantage of this approach, of course, is that I can make a Lambda and I can pass it any kind of other Lambda that I want to when I actually execute it. Okay, Lambda variables, wow. So how does this work with named Lambdas? Okay, so here's the Lambda we've been looking at with its Lambda variables. So supposing we make this Lambda into a named Lambda called first class, then we'd pass it the arguments 7, 35, Lambda, ij, etc. and when we called it up, we'd get the same answer, 42. And then we could make the lambda ij j plus I into a named lambda called lamad2, and we could call it up first class 735 lamad2. So then this is a way of sort of encapsulating things into named lambdas in a nice way so that we can reuse them throughout the workbook in different places. And okay, so this makes it a little more obvious that I could pass this first class named lambda, any named lambda I like, as the second position, providing of course that it took two arguments, two parameters. Well, I hope you're with me so far, because life gets a little bit more complicated when we start using let to create lambda variables. Oof. Okay, so let's look at this little example. So we've got a lambda and we've got this let function in the middle as the calculation expression for the lambda, and it says let s be lambda a b b plus a, very familiar looking lambda, and then for the calculation expression of the let, we're going to use s, which is the lambda variable, with x and y as its arguments. So let's trace things through. So overall we're giving it the arguments 7 and 35. So the 7 goes to x by position, the 35 goes to y by position, and then s is the lambda that's used in the let calculation expression, and it's picking up the x and the y by name because I'm still within the scope of the lambda. Okay, so within the scope of a lambda and the scope of a let, parameters get passed by name, although the arguments from outside get passed by position. Okay, so you've got to work this through when you see one of these in real life quite slowly and figure things out using these rules. Parameters to calc expression by name, arguments to parameters by position. Yay! Okay, so here's a slightly more complicated lambda. It's actually a simplified version of a lambda that was created by our friends at Microsoft Research. And I produced this simplified version in order to try and understand what on earth this lambda was doing. Okay, so what we're actually doing is something very simple. We're just concatenating two strings in an array using this lambda. But we're wrapping it all up in this other lambda. So we've got 3 arguments. The first is an array, ZZ and WW, array of strings. The second argument is a lambda, A, B, A, ampersand B, so that's just concatenating A and B. And the third argument is an empty string. So that gets passed by position to the parameters of the lambda, array, f, and init. So f is the lambda variable. And then we've got a let function which is going to use those parameters to do the calculation. Okay, right. So let's look at the actual calculation that's going on inside the let statement. So the let statement is the calculation expression for the lambda, and of course it has its own calculation expression. So let is defining s as a lambda variable, which is this lambda here, lambda ij, whoops, it's getting another, this case a named lambda called lamscanner. I'm not going to go into what that does, but it's passed these parameters, these arguments, array, f, init, I, and j. So array is going to come from the first parameter of the lambda because we're passing by name. The f is going to come from the second parameter of the lambda because that's passing by name. Init goes to here, and the ij comes from the ij of this lambda, and then we use it in the calculation, and we're passing it to passing s to arguments, the rows of the array and the columns of the array. So this would actually be 1 because there's only one row in this array, and the columns would be 2 because we've got 2 columns in the array. And f, of course, would be this this lambda here. So all this is really doing, when you boil it all down, is it's a dynamic array function using lambda, which is automatically resizing itself depending on the size of the arrays that you pass it. Okay. So which Excel functions are actually capable of using lambda variables, capable of being passed a lambda to do things without resolving the lambda before it gets to the function? These are the lambda capable functions. Lambda and let, obviously, as we've seen, and some of these new lambda higher order functions, lambda helper functions. By row, processes each row in a dynamic array in turn. By column, processes each column in turn. Map allows you to apply a lambda to each element in an array in turn. Reduce, we pass it an array and you give it a lambda that accumulates stuff to a single value. So think of it as a super powerful version of aggregate, sum, average, all those kinds of things. Scan doesn't accumulate, but it also shows you, doesn't give you a single value, it gives you the intermediate values in the aggregation as you're going along. And make array finally just creates an array of the size you choose, which is a useful kind of thing to build dynamic arrays. Now we're going to be using some of these in the next set of functions that we're going to look at, which is my example, winding up with the gradings function, one function to rule them all. So these are the functions that we're going to develop, starting with grade, which is a function to calculate letter grades from percent scores. Then percent to grade point, which gets the grade points from the percent scores. Then grade points from grades, and grade point averages from either percent scores or letter grades or grade points. And then finally the grading functions, which basically is a lambda function that you pass other lambda functions to in order to do any of these kinds of calculations. It's fairly straightforward to convert a score to a grade using XLOOKUP. We need a table somewhere which gives us the grades and their scores showing, and the grade point, the equivalent grade points. So I'm using a defined name containing an array of the grade scales to make it easier to transfer things between workbooks, so that all the lambdas and the defined name can be easily transferred. I don't actually need to have a table, this table, in each workbook. So if we look at the function I'm using, I'm looking up a score of 66 against the grade scales here and returning a value from there. Let's look at that using my Formula Explorer tool, and we can see that grade scales looks like this. It's a defined name that's got this data. So if we take the second column of grade scales using an index function, we get the 100 down to 1, and the first column gives us the letter grade score, and then the -1 on the XLOOKUP tells it to look for a value which is to find a row which is equal to or less than the value we're looking up. Let's if we look at the XLOOKUP itself and trigger off the help, we will see what the parameters of the XLOOKUP actually show. So these are the first few. So what we've got for the -1 is look for an exact match. If not found, return the next smallest item. So we look for 66. It's not actually there. We find the next smallest item, which is the 64, which is a B+. So that's what we return. Now, of course, this is all very well, but we want to do this dynamically. We want to do it for a whole set of scores. The scores need to adjust as we add more data or more students or whatever it is. So to do that, we need to turn it all into a lambda. Right, so I've built this function, and let's have a look at it with Formula Explorer to see what it actually looks like. I'll get rid of that. So in the middle here, we've got the XLOOKUP, which we had on the previous for the single one, for a single %. So it's the same thing as we had on just previously. If the percent's greater than 0, we don't want to do this lookup if we've got an empty value in the scores. Either we don't have the data yet, or somebody's skipped a particular course for a valid reason. So we've got a lambda. Now let's start with this. We've got the scores that we want to convert to letter grades. Not very many students. Some of them may or may not be familiar to you. And here's the scores, randomly chosen, I have to say, for the months of the year, months of this year. So that's the parameter that we're going to pass. Sorry, that's the argument that we're going to pass to the lambda function. So it's going to arrive as the percents variable in the lambda. Then we use map. Now map is a function that allows us to apply a lambda transform to every single element in the array that we're passing to it. So we map percents, which is the grades that we passed in, and the lambda we use looks each individual percent in the percents array. If the percent's greater than 0, we look it up in the grade scale and named range and return the letter grade. So that's a fairly straightforward method of wrapping things in a lambda, using map to apply a lambda transform to each element of the array. So the next function we want to develop is very similar. We just want to calculate the grade points from the percentage scores instead of the letter scores. So all that really means is instead of returning a value from the first column, which is the letter score grades, we want to return a value from the grade point. So if we look at the function. This is the one that returns the letter grades, and we can see that the one it's returning is the first column, this one here. So all we've got to do is we want to return the third column instead of the first column, which will be the grade point. Okay, so we'll save that back to the cell. Yeah, okay, we got it. Now, okay, we could if we want to save this back as a name. At the moment, it's a in-cell lambda. So really, what we need to do is to convert it to a named lambda. So we click this button here, and we can store it as a named lambda. There it is. We just give it a name. We can add a comment, and away we go. Of course, another way of doing it is fairly simple. We take the formula itself. We just copy all the bit excluding the arguments that we're passing to it, and we start up Name Manager. Well, I'm using Name Manager Pro because we've got a much more sensible area to work with. Tell it we want to add a new thing, and then I can paste that in. Yep, and I could give it a name and click Save, and we'd be there. I've already done that anyway, so I'm not going to do it again. Okay, we can see the various functions which I've developed here in Name Manager Pro. Okay, so that's 2 down. We've got a few to go. Okay, next up, we need to build a function that dynamically calculates grade points from the letter grades. Okay, so yeah, let's have a look at that. Again, it's fairly straightforward. We're using very similar XLOOKUP. In this case, we're looking up the first column in the grade scales, which is the letter grades, and we're returning something from the third column, which is the grade point. Okay, so the only funny thing here is I've got an is text in there to make sure that in this case we are actually looking up letter grades rather than anything else. Otherwise, this function won't work. Again, I'm passing it B4, which is the output from the previous function. Okay, actually in this case I'm using the grade function, which is the named lambda version of the scores to letter grade function. Okay, so again, very straightforward use of map to do this. Oops, I forgot to mention one thing. We've got to change the one argument in the XLOOKUP to make it look for an exact match rather than the next smallest item. So we've just removed one of the parameters because the default for XLOOKUP is in fact exact match. The next thing to do is to calculate the grade point average from grade points. Now, we only want to get a single value for this, so we've got to process the array of grade points row by row and basically calculate the average of the grade points. So that's a fairly simple calculation. We just add up the grade points and we divide by a count of the grade points. So if we look at the actual lambda, oh yeah, we can see here what the scores are, by the way. Liam and I are bottom. Sorry about that, Liam. And Celia and Jan Carroll are top. Ah, okay. With a few other things in between. Right. I assure you these are purely random numbers. So let's look at the function in a bit more detail using Formula Explorer. Let's start that up. And away we go. Okay, so we're passing this lambda the grades, as you can see before, and that arrives in the lambda as scores. Because we want to process this by row, we've got to hand it each individual row. So what the by row function does, you hand it an array, and it then hands off each individual row to its lambda. So the lambda here is working on each individual row, is run for each individual row in the scores table. So we start by checking if the count of all the items, all the grade points in the score row are greater than 0. Then we take the sum of the grade points and divide by the count of the grade points. This is just simply to avoid doing a divide by 0. Now you'll notice here we're using the GPT function. This is the named lambda version of the scores to grade point lambda we saw earlier on, but it's slightly more generalized. So let's look at this grade point named lambda in a bit more detail. If we click on the GPT in the Formula Explorer, it expands the name lambda and shows us what its refers to formula is, as we've got down here. Now we can pass it either a percent or a grade, letter grade, or indeed we can also pass it an array of grade points. God, there's not much point in doing that because that's just going to get passed straight through. So this first if test counts the values in the score row that we've been passed. And the count function, of course, only counts numbers. It ignores empty cells, blank cells, or letters. So if we're passed a letter grade, it will get 0. So if the count is greater than 0, we've either got scores or we've got grade points. So the next test is to say, well, okay, if the average, the sum of the grade points divided by the count of the grade points is greater than 10, then we've got percents, scores. So we want to convert the scores to grade points using this name lambda. Otherwise, if it's less than 10 but it's numeric, then we've already got grade points, so we just pass the grade points straight through. If on the other hand it's not numeric, count is 0, then we use the grade to grade point named lambda to convert letter grades to grade points, and that gets returned. Okay, so it's handy to generalize these functions in a bit better way. In real life, we'd probably add a bit more error handling, but for demonstration purposes, this is fine. Now you'd think that because this is a fairly simple averaging function, that you could use the reduce lambda function instead. Instead of all this lambda bit here, should be a reduce that works on each individual score row. But I have to admit I haven't been able to figure out how to make that work. I'm sure somebody cleverer than me can do it. I have a feeling that might be the better approach. Okay, now we're finally at the point where we can develop the master function Gradings. This is going to work by passing Lambda variables, which are predefined named Lambda functions, to the Gradings Lambda, so we can make this one function calculate either grades from percents or grade points from percents or grade point averages or basically any combination you like. Before we do that, I think we ought to do something about Liam's rather poor performance here. I think it's time we gave him a few higher scores, see if we can't bump up his grade point average a bit. There we go, we got him out of 3.3. That should do you, Liam. And just to demonstrate this really is all happening dynamically, we'll add in some more numbers. Here we go, 78 for young Carol. And then let's delete Joe completely. Delete rows, zumph. And so everything dynamically recalculates as we change things in the table. Okay, now let's change this. So instead of calculating the grade, let's turn this into grade points. So what we do is we change the variable that we're passing from grade to grade point. Whoops. Grade point. And ping. All the gradings are now showing as grade points because we've passed it a new lambda variable grade point. The overall gradings haven't changed. Interestingly, after we deleted Joe, the position of that didn't move. Be interesting to try and find a way around that. Okay, so we can give it a grading, or we can change that to we can make this calculate a grade point average. Which is a bit silly since we've already got it over here. But anyway, okay, let's undo that. And let's look at the actual function itself and see what it really looks like. Okay, gradings. Well, we're just passing it the data and the lambda variable. So the actual gradings lambda itself, when expanded, it's got two parameters which we pass two arguments to. One was the lambda variable, which was either of the named lambdas, and the other is the data. And so the lambda itself just takes those as parameters. Then its calculation parameter is the lambda variable itself, grade func, supplied with the data. So it's really very, very simple to do. Now, of course, we could have built the function a more conventional way rather than using lambda variables by giving it a parameter switch that said, if it's a 1, do grade point calculations. If it's a 2, do letter grade calculations. If it's a 3, do grade point average calculations, or something like that. Or it could be an alphabetic switch. But really, the ability to pass lambda variables, predefined lambda functions, to other lambdas brings a lot of power to Excel. It may seem a little complex initially, but as you've seen, really it's quite straightforward to do, and brings a whole set of new options to Excel and lambdas. Now, Excel comes with a built-in name manager. And if you've ever tried to work with this, work with lambdas in this, you'll soon realize that it's pretty much impossible. You've got this tiny little box down here to try and change them in. Similarly, when you're creating a new one, you've got a huge box for comments and no space at all to edit the actual formula. So it's pretty much a waste of space as far as lambdas is concerned. Now, Jack Williams at Microsoft Research has built this named Lambda Editor, which is quite cool. It's got some good examples and tutorials. If we open that, we can see the examples that it's got. I don't know, let's pick one, conversion rate, okay. So we can see we've got indentation possible, we've got color-coded function names, we've got some tooltips available. Yeah, quite a lot of stuff there. You can store different sets of them, you can copy to the clipboard, you can import them from JSON. The sync button syncs this whole lot up to Name Manager, so then they can travel with the workbook in a conventional way. So it's quite a good little tool. If we look at Name Manager Pro, oops, there's a free version of this built by Jan Karel Pizze, which you can download from his website, and that gives you much more space to edit lambdas and create them. Look at that lovely space there, where you can copy them from other things, you can make them global, you can hide them, you can do all sorts of lovely things with it. So that's definitely worth using. You've seen me using Formula Explorer. That's at the moment a fairly experimental tool as far as lambdas is concerned. There are bits of it that don't work the way I want them to. I'm still working on it. But it does integrate well with Name Manager, so we can use them together. You can see the lambdas in nice indented form. You can modify them here, make small changes to them. It's not a full-blown editor, and save them back to Name Manager. If you pick let's do that again. So if we take grade point, when you push the Analyze button, it asks you for, that's a name manager. It doesn't have any parameters, so you'd have to give it a parameter like that to make it properly functional. Then you could save it back into the worksheet, or you could copy it back to Name Manager. Also, within Formula Explorer, you can get a list of all the Lambda variables, pick the one you want to look at. Let's pick grade to give you G, and okay, again it wants to get a named Lambda argument. So these are tools which show you how much better it could be working with lambdas, and we just have to hope that at some point in time we'll get some proper tools built into Excel. I'm sure we will. It's just a matter of time. Well, that's the end of my session on Lambda variables, these mysterious cousins of the new Lambda function. I hope you've enjoyed my rambles through various complex and less complex things. I think they're here to stay, and I think as Microsoft and the Excel team develop them further, they really do add a lot of power to Excel and will be seen as and become much more widely used. Thank you for listening and watching this show. All the best. Bye.